Hi guys, Lever here from Bright Young Brains. So this is the second portion, right, of us going through grade 12 differentiation. So in the previous tutorial, right, on differentiation, we were using y and y prime. So we're going to start making use of f of x and f prime, right? Because in grade 12, those are the symbols you're going to use more often. So we already said that this is the main way to differentiate. What we need to keep in mind is that you will not always have a single term that you need to differentiate. There are cases where you have multiple terms in an expression, and differentiating that expression, it's a matter of just differentiating each term individually. An example of that is if we had g of x and they want us to differentiate this expression, we are just going to end up with 15x squared minus 4x. And all we did was 3 multiplied by 5 gave us 15, and then 3 minus 1 gave us a 2. And then here we just did the exact same thing again. We just used this law. 2 multiplied by negative 2, this gives us a negative 4, and then 2 minus 1, this gives us a 1. That's why we didn't write anything there, because the value there is just a 1. So what we're going to do is we're going to work on how to differentiate expressions where x has an exponent of 1 and where x has an exponent of 0. So I'm deliberately saying where x has an exponent of 0 because you are probably going to be asking, what's that? And all we're trying to refer to is a constant, right? A constant is literally just a term where x has an exponent of 0. So you want to just keep in mind stuff like that. So to give meaning to what we've just mentioned now, if g of x was a bit more chunky, right? Let's say it had more terms than just 2. Let's say it had also negative 3x and then a minus 1 at the end. Let's say it was like a full-blown cubic function. If you had to differentiate this expression, nothing changes really. You just still differentiate each term individually. So the first two, we already know that that's just going to be 15x squared minus 4x. Now, when you differentiate these last two, first key thing you want to remember is anytime you differentiate anything with 1 as an exponent, for example, what we have here, right? If you're going to differentiate negative 3x differentiated, all that you're going to say is negative 1, or rather, sorry, 1 multiplied by negative 3, that's going to give you a negative 3, right? And then here you're going to say where 1 is, you're going to obviously just finish the process, right? 1 minus 1 where 1 is, and this will leave you with x to the power of 0. And we know that anything where it's a variable to the power of 0, this is just a 1. So here we will just have negative 3 on its own. So this makes it look like a complicated process, but it's actually quite simple. This is all a way of us trying to say that if you ever have to differentiate anything where the exponent is a 1, this expression differentiated will always just be the coefficient on its own, right? Because of our differentiation law, our main one in grade 12. We know that nothing funny happened. We still followed the same steps, right? We know that 1 multiplied by a negative 3 gave us a negative 3. And then where 1 is, we know we have to still minus a 1 there. So this ended up being 1 minus 1, which is just a 0. And we know that anything to the power of 0 is just a 1. So we know that this is basically just saying negative 3 times 1, which is just a negative 3 there. That's why we just have a negative 3 for this term there. Now, our other law, or not a law per se, now our other method of differentiating a constant. Here we have a constant, and we said, firstly, this is an entire cubic function, and they want us to differentiate that cubic function. And we said all you do is differentiate each term individually, one by one. This we differentiated, this we differentiated, that we differentiated. Now this negative 1, we also need to differentiate it, right? So law is, or the law, whenever you need to differentiate a constant, the law is that the constant just falls away, literally. we have a constant. If you're going to differentiate this constant, it just falls away. I'm almost tempted to put a plus 0 there, right? However, I'll just leave it open, right? What I will put down here is the constant disappears. And I hope I've spelled disappears correctly there. I'm not very good at spelling. I'm good at math though. Anyways, so yeah, the -1 just disappears there, right? And that's it. This function differentiated will just end up as 15x squared minus 4x minus 3. And then we said that a constant differentiated, it just disappears. If I have edited that out, it just means I spelled it wrong. If I left it, then I spelled it right. So let's just see what happens when I edit this video. Hi guys, Diva here from Bright Young Brains. So we're working on differentiation, right? Specifically for grade 12s. And today we're mainly going to showcase 3 main scenarios that we want to keep in mind whenever we differentiate. So there are cases where you will not be bluntly given expressions nicely packed like this. So what we mean is there are cases where you will be given expressions, yes, asking you to differentiate. However, you will have negative exponents there, and cases where you have surds there, and cases where your expressions are in fraction format. So anytime you have to differentiate and you are not given something, this is something that's this blunt, you will always need to firstly put it into a scenario or put it in a format that is this blunt before you can execute this step, right? So from the top, when you're given an expression that you need to differentiate and it's in one of these 3 formats, you cannot differentiate it in grade 12 from the get-go. You will have to simplify it first and then differentiate. So that's what we're going to show. So what we have here, right, is an expression, and with an expression like this, if they ask us to differentiate, we won't be able to differentiate immediately. Main reason is this is something that is not in our normal differentiable format, right? This expression here is not in this format. We cannot clearly see a coefficient and a value for a and an exponent. That's why we are not able to differentiate this immediately, especially in grade 12. In grade 12, if you're going to differentiate expressions like this, you will need to put them in this format first. So what we're going to work on is how you go from this format to a format that is differentiable, if I can put it that way. So if we're given f of x in this format, you will first need to simplify f of x. And simplifying f of x, this is what it's going to look like. Now, all that has happened is anytime you have a fraction with your variable to the power of a value under or where the denominator position is, anytime you have anything in this format, it's a fraction and our variable is on the denominator to the power of an exponent, and we need to differentiate the whole thing. If you're going to need to differentiate, we need to keep in mind that all that happens is you take your value for x with its exponent up, you take it to the numerator position, and then once you take it to the numerator position, you need to make sure that you change your sign for your exponent into a positive value, or rather you just need to interchange your sign. So meaning if you were given a negative value down here, just rewrite it with a positive value up there. If you're given a positive value down here, just rewrite it with a negative value at the top. So once you have this in this format, we can now differentiate this because all these terms, right, this term and this term are in this format that we can differentiate. So anything in this format, we already mentioned that if we have to differentiate, it's all a matter of multiplying the coefficient in front and then subtracting 1 from the exponent. So that's what we're going to do here for these two. There we go. Now, what you want to take note of is how here, when we were differentiating the negative x to the power of negative 3, keep in mind your signs, as always. Here we had a negative 3 multiplied by a negative 1. This is going to give us a positive 3. And then another key thing is, you see where the exponent is. This is going to read negative 3 minus 1 because of our law. So negative 3 minus 1, that's going to give you a negative 4. So this here, you mainly usually don't want to just leave it like that. The reason is, anytime you're working with differentiation, right, you are normally asked to leave your answers with positive exponents. What that means is, you are given a question like this. Yes, you have differentiated. However, if you have a negative exponent there, you will usually lose at least about a mark or so if you don't put it in a format where the exponents are all positives. So what we mean is, if you have something like this with a negative exponent, all you want to do is, you've already differentiated, right? All you'll need to do is, whatever variable has that negative exponent, you just take it under the coefficient, right? Just like what we've done here. The x to the power of negative 4, the whole thing went under the 3, and then it gets a positive value there. So in the beginning, before you differentiate, you have to take it up. It gets a negative exponent. When you're done, because you will usually be left with a negative exponent, you just reverse the process. You just take it back down, and then it is now finished. And key thing is, you see how here, when we have differentiated, we have made sure that we write the appropriate symbol. And then here, even though we are now just simplifying our already differentiated equation, you always want to keep in mind, just write the f prime in front as well, so that you don't get penalized unnecessarily.